Step under the yellow tape, detectives, and welcome to the Explainer. Today, we are opening a very special, highly sensitive file from the archives. Consider this a full forensic case file investigation into one of the most notorious repeat offenders in the entire Cambridge AS and A-level mathematics 9709 syllabus, the binomial expansion. I'm your host, and today I'll be acting as your lead detective. Now listen up, because we are going to treat this mathematical topic a little differently today. We're not just looking at a set of formulas to blindly memorize from a textbook. No, we are treating this past paper like an intricate, high-stakes crime scene, absolutely packed with hidden forensic clues. We are going to secure the perimeter, pull out the magnifying glass, and examine exactly how the Cambridge examiners, the ultimate judges of our case, look at your exam papers. Whether you are aiming to secure those critical foundational method marks, or you're trying to elevate your profile to that top-tier grade boundary, you need a systematic, completely airtight approach. So grab your notepad, get your highlighters ready, and let's process the scene.
Okay, let's dive into this. The quote you're looking at isn't just a casual observation. It comes straight from the highest authority. The Cambridge Principal Examiner reports state explicitly that the binomial expansion of a plus b to the power of n for a positive integer n is one of the single most misunderstood areas in the entire mathematics syllabus. This isn't just a minor speed bump on paper 1. This is a prime location where thousands of perfectly capable candidates literally hemorrhage marks every single exam series. It's a massacre out there. They walk into the exam room, the clock is ticking, they see a binomial series question, and they just panic. They start throwing completely unstructured algebra at the page, just hoping something, anything, sticks. But here is the reality check. Examiners are essentially forensic auditors. They are looking for a flawless chain of custody in your logic. When that logic breaks down or when you skip a little step, the marks vanish into thin air. Our mission today is to fix that right now. We are going to reverse engineer the examiner's mindset so you can build an unassailable, bulletproof case in your very next exam.
All right, here is our investigation briefing for today. We are going to tackle this case in 4 distinct phases. First, we'll examine the binomial expansion evidence. Second, we'll map out the method mark strategy. Third, we'll review the forensic examiner warnings. And finally, we'll lock in our protocol. Deconstruct, solve, evaluate. Section 1, the binomial expansion evidence. Let's head into the evidence room and look at the theoretical foundations of our crime scene. Pinned to the board right here is our prime suspect, the core parameters of our investigation, the series of the binomial expansion of a plus b to the power of n, specifically where n is a positive integer. Now, on the surface, to an untrained eye, this might just look like a standard, harmless formula you'd find sitting in your Cambridge formula booklet MF19. But a true forensic mathematician knows that a formula is just a tool. The real mastery, the real detective work, is in the application. This conceptual framework relies heavily on incredibly specific mathematical principles. You need to lock down exactly how elements like combinations, specifically calculating n-choose r using factorials, generate the precise coefficients for every single term in the sequence. You have to ask the investigative questions. Why does the power of A progressively decrease step by step while the power of B systematically increases, leaving a perfect numerical footprint? How do these binomial coefficients act as the load-bearing structural pillars of your expanded sequence? If you don't deeply understand the why behind calculating those factorials and indexing those powers, your mathematical evidence will collapse under cross-examination in the examiner's court. Now let's look at the examiner's precise grading blueprint. This table maps the assessment objectives directly against the cognitive domains you must demonstrate. Look at how the expectations scale up. First, we have knowledge and understanding. This is your standard data tracking, recognizing the formula and knowing how to plug raw numbers into it. It's the baseline, but listen to me, if you stop there, you completely cap your mark potential. You become like my junior partner, Agent Alex, a procedural detective who gathers vast mountains of raw physical evidence, copying out long textbook definitions, but completely fails to build a coherent case motive. Next up is application. This is where you adapt that standard formula to a slightly unfamiliar context. Maybe you're dealing with fractions or tricky negative coefficients, or you need to isolate a specific term that is independent of x. Finally, we reach the highest domain, analysis. This requires deep, cross-topic critical evaluation. The principal examiner reports explicitly highlight that candidates who reference cross-topic connections, perhaps linking the binomial expansion algebraic structures to probability distributions or integrating it with complex polynomial algebra, are the ones who secure the highest marking bands. You can't just be an Agent Alex, and you definitely can't be like our other partner, Agent Sam, a fast-acting rookie who jumps to immediate conclusions, skipping vital forensic confirmation steps and completely missing the examiner's command word constraints. You need to build a deep, analytical logic string. Section 2. The method mark strategy. Let's shift our focus to the procedural framework where the real marks are hidden. To secure those procedural method marks, you must follow an exact, unyielding systematic processing sequence. Think of this as your official chain of custody for handling mathematical evidence. I see Alex and Sam argue over this at the precinct all the time. Alex wants to overload the page with paragraphs of generic formulas, while Sam just wants to scribble down a final answer to save time. Both of them lose the case. Here's the actual protocol. Step 1. Identify key elements. Before your pen even hits the paper, extract the relevant data. What is the precise value of A, B, and N? Step 2. Apply relevant principles. Lock in the correct analytical framework for the specific term you need. Step 3. Execute analysis with clear working. This is where most students completely drop the ball. Your working must be incredibly transparent. If you skip algebraic steps in your head like Sam does, the examiner cannot legally award you those process method marks. They literally need to see the gears turning on the page. Step 4. Verify results. Did you check your negative signs? Does the expansion logically follow the binomial theorem? Step 5. Present in appropriate format. You have to present a coherent thesis. Writing a bunch of disconnected numbers is like handing a judge a box of random puzzle pieces. Following these 5 steps acts as an absolute insurance policy for your final grade. Case file freeze! Before we reveal this top-end paragraph structure and the presentation rules to help you clear your upcoming Cambridge sessions, make sure your intelligence feed is fully secure. Take a second right now to subscribe to Ace the Exams at the handle @AceTheExams and turn on all notifications so you never miss our weekly forensic exam updates, whether you are cracking cases at IGCSE, all levels, or AS and A levels. Okay, tape rolling again. So the crucial point here is that presentation is not just about making your paper look pretty. It is the formal legal documentation of your mathematical evidence. The examiners mandate incredibly strict presentation conventions. You absolutely must use correct terminology. If they ask for the coefficient of x cubed, don't write out the entire 5-term expansion and expect the examiner to play a guessing game to find your answer. Use appropriate formats. Use your brackets meticulously. A missing bracket around a negative sign is the #1 cause of computational collapse. I've seen massive 10-mark cases thrown out because a candidate forgot a parentheses and squared a negative incorrectly. Finally, clear annotation. Guide the examiner through your logic. If you use a specific property of combinations, a brief, clear line of working acts like a lighthouse, guiding the examiners straight to your method marks. Section 3. Forensic Examiner Warnings. It's time to open up the autopsy report and look at the most common crimes. Here we have it on the evidence board, the top 3 forensic mistakes examiners flag when cross-examining student responses year after year. Mistake number 1. Answers are too vague. Candidates often provide shallow, descriptive statements rather than precise algebraic details. They write out a general formula they memorize, but completely fail to substitute the specific values accurately. Mistake number 2, format and presentation unchecked. As we literally just discussed, dropping brackets, losing negative signs, or misaligning your powers leads to a total, devastating collapse of the mathematical argument. And mistake number 3, which is absolutely the most fatal error you can make, answers not specific to the given context. The classic examiner alert is that candidates provide generic, rote-memorized answers that do not address the unique scenario presented in the question. If the command word asks for the first 3 terms in ascending powers of x, and you give them descending powers because that's how you practiced it at home, you have completely ignored the constraints of the case. Your evidence is useless. And this brilliantly illustrates exactly what we're talking about. Look at this comparison. On the left, we have a counterfeit answer, a generic mathematical response where a student just blindly writes out the binomial formula, throws in some raw numbers without stating which term is which, and hopes for the best. It's a shallow, descriptive statement, the exact kind of thing Agent Alex tries to submit. It lacks all analytical logic. Contrast that with the context-linked scenario-specific answer on the right. This candidate explicitly states their substitutions up front. They isolate the specific term the question demanded using precise general term formulas. They build what we call the Peel matrix for math: point, evidence, evaluation, logic. They state the point, substitute the specific evidence from the prompt, evaluate the algebra flawlessly, and conclude with a logical, formatted answer. They link every single line of their working directly back to the parameters established in the prompt. When an examiner cross-examines that context-linked answer, it holds up perfectly. There are 0 logical gaps. It is an airtight, top-band evaluative argument. Section 4. Deconstruct, solve, evaluate. Let's move into the final, critical analysis phase required for top-tier problem solving. All right, detectives, I'm handing the case files over to you for a live forensic check. Let's walk through this elite deconstruct, solve, evaluate framework that the absolute top-scoring candidates use to build an airtight case. Think of this as your 3-step question scan. First, decode what is actually being asked. Extract the exact constraints. Next, we do a clock budget allocation. Break the problem into logical steps and decide how much of your exam time each part actually deserves. Then you solve systematically. Now, here is challenge 1 for you, the visual clue scan. When you look at a complex case study or a multi-part binomial question, imagine a 60-second visual countdown timer ticking down right now. Can you extract the single highest yielding core trend before the clock runs out? Are they asking for a specific term, an approximation, or an expansion up to a certain power? Once you have that, you lay out your evidence with flawless notation. Check for reasonableness. If you end up with a massive unwieldy fraction for a simple integer coefficient question, you need to trigger a mid-case evidence audit. Finally, make your justified conclusions, clearly stating your final answer so it perfectly mirrors what the examiner asked for. Evaluating the quality of your evidence requires identifying limitations and alternative interpretations to justify your final conclusions. The very best candidates don't just mechanically solve, they actively evaluate. In Cambridge mathematics, this means you must constantly question your own assumptions while you are in the exam room. Did you assume a term was positive when the initial expansion actually dictated it should be negative? Here is challenge 2. Identify the counterfeit answer in your own work. Look at your paragraph of working. Can you locate the exact sentence or algebraic step where a false logic jump or descriptive fluff destroys the overall mark integrity? Did you consider different perspectives? For example, could you solve this problem by expanding the whole entire expression? Or is it vastly more efficient to use the general term formula to snipe just the single coefficient you actually need? You must justify your decisions with clear, undeniably visible evidence on the page. You have to course correct before that exam clock hits 0. And with that, Alex, Sam, and all of you watching, our case resolution bar is sitting at a flawless 100%. The investigation file is officially closed. As you prepare to face your own exams, I want to distill this session down to a final, provocative question that you must ask yourself every single time you sit down to practice. Have you rigorously linked every single mathematical step back to the given context of the scenario? Remember the 3 universal rules we covered today. The 3-step question scan to decode the prompt, the clock budget allocation to manage your time, and the final evidence audit to review your checklist of brackets and signs. The binomial expansion isn't just about moving abstract numbers around a page. It is about proving a logical sequence beyond a shadow of a reasonable doubt. If you can master this forensic, highly structured approach, you won't just avoid the classic traps, you will secure the highest possible marks on your paper. If you want to keep your analytical skills sharp, make sure you subscribe to Ace the Exams at the handle @AceTheExams. Click that notification bell right now for our weekly grade masterclasses and drop a comment down below sharing exactly which Cambridge subject and level, whether it's IGCSE, O-Level, AS, or A-Level, you are preparing to conquer next. Keep your evidence audited, trust your logic, and I will see you in the next investigation.